Okay, here's part two of special right triangles. So these problems are going to look a little harder. Sometimes the orientation is different. And then also, the other thing about them is that you're not necessarily given that side that kind of is the key to the rest of them. So here's our first one. Okay, we know this is a 45, 45, 90. And the reason why we know that is because the two legs are identical. So for some people, they really like to rearrange it when it looks like this. So they like to put it in terms of how we're used to looking at our triangles. Okay. So we have this, and then we have our table. Okay. So what we know is that opposite the 45-degree angles, we always have A. Opposite the 90-degree angle, we have A root 2, okay? And if you're forgetting where this comes from, that's a terrible drawing, but this comes from A root 2, okay? Okay, so now back to this problem. So we know that these are the way the ratios play out, but let's go ahead and put in what we have. So what we have is opposite each of the 45s is a Y, and then opposite the 90 is a 28. Okay, so here's the problem. If we look, remember our goal is to look from here, and see if there is one that has only one missing variable. Well, it's definitely not here. And remember, finding A is kind of like our key into the problem. So we still have to do that, okay? But we're just going to do it with this side. So what we're going to do is we're going to say we're going to set up an equation. So A root 2 in this case is equivalent to 28. Okay? And our job is to find A. So what we're going to do is we're going to isolate A. We're going to get A all by itself. And what we end up getting is A equals 28 over root 2. And if A equals 28 over root 2, we know that we can't have a radical in our denominator. So I'm going to rationalize. I'm going to multiply the top and the bottom by the root that I want to get rid of. So I get 28 root 2 over root 4, which is the same as 2. And then if I look at this, remember you simplify outside of the square root and inside. And if I look, my inside simplified, but 28 divided by 2 can simplify evenly. And so if that's the case, 28 divided by 2 is going to be 14. And then we're left with root 2. Okay, so what that did was that found A for us. So if A is 14 root 2, then what that means is Y is 14 root 2, and Y in both places is 14 root 2. Okay, so again, finding that A value or finding that value that's by itself is the key to finding the rest. Okay, so there's one problem. And we're going to do something very similar for our second problem. This one's just a 30, 60, 90 triangle. So if I look at this triangle is set up very oddly. I'm having a hard time seeing this. So what I'm going to do is I'm going to set it up and write it as a triangle that I can kind of recognize a little better. So opposite, if I rearrange it, opposite my 30 is D, opposite my 90 is C, and opposite my 60 is 25. Okay, so I'm going to even cross that out, okay? So now what I have to do is I have to use my table or my triangle. Now I'm going to show you this one a little differently because some people prefer this method rather than memorizing, this table up here. So instead they memorize the triangles and they go from there. So if we do that, I'm going to write down my 30, 60, 90 special right triangle. So this is A, this is 2A, and this is A root 3. This is something we developed. This is something you need to memorize, okay? So if we do this, what I notice is I have some values that are corresponding. So A corresponds with D. 2A corresponds with C. And A root 3 corresponds with 25. So what that means is, just like in the table, I'm trying to find one of these colors that has only one missing variable. Well, it's not green. I have too many missing variables. It's not orange. I have an A and a D. So it is going to be pink. And so because these are corresponding, that means they're in proportion, which means I can set them equal to each other here. So A root 3 equals 25. And this should seem pretty similar to the one up above, okay? So if I'm going to now rearrange for A, I'm going to divide both sides by root 3, and I'm left with A equals 25 over root 3. I'm going to rationalize the denominator, and I'm going to multiply both the top and the bottom by root 3. And I get 25 root 3 over, remember, root 3 times root 3 is root 9, which is equal to 3. And 25 and 3 does not go evenly into 25, okay? So we can't simplify that. We're going to leave that. So this is my A value. So then what I do is I go back down to here and I say, okay, well, if A is equal to 25 root 3, that means side D is equal to 25 root 3 over 3. And then this side is double A. Okay, so that means this side is, I need to do that off to the side. So 2 times A is equal to 2 times 25 root 3 over 3. And so to multiply fractions, I multiply the top and the bottom, and I get 50 root 3 over 3. I also can't divide nicely. That would give me a decimal, so I get to leave it like that. So now that answer becomes C, 50 root 3 over 3. So there are my answers. Now, if you don't like looking at it like this, what I could have done is I could have done my table, 30, 60, 90. Opposite my 30 is A. Opposite my 60 is A root 3. And opposite my 90 is 2A. And then I could have put these into it. So opposite my 30 is D. Opposite my 60 is 25. And opposite my 90 is C. And then this would have been my driver to do all of this work. Okay. Those are going to be your hardest kind. Those are the ones that you don't have A. So you can't solve it nicely. If we had A, we could solve this one nicely and this one nicely. But when you're given the thing with the root, whether it was here or whether it was here, those are going to be your harder problems. So you have to do a little extra work to find A. But ultimately, the goal is always to find A and then find the other sides based on A.